Alright, today we are going to be graphing linear equations in slope-intercept form. So first question is like, what's a linear equation in slope-intercept form? Well, linear equations can always be written in the form y equals mx plus b. To make that more concrete, maybe think of something like y equals, say, 3x plus 1. Here, 3 is m and 1 is b. So when we graph an equation, we're just plotting a bunch of points that represent where the equation goes in the xy plane. So for this y equals 3x plus 1, for example, let's draw an xy plane here. This will be x, this will be y. So when x is 0, what's y? Well, we plug 0 in for x here and get 3 times 0 plus 1, so that's 0 plus 1, and then y is just 1. So I'll make a little table here. It's x and then y. Alright, how about when x is 1? What's y? Well, 3 times 1 is 3, and then plus 1 is 4. So let's plot 1, 4. Maybe it's around here. And what about negative 1? Well, when we plug in negative 1, we've got 3 times negative 1, which is negative 3, then plus 1 is negative 2. So now let's plot that here. And we're just going to end up plotting a bunch of points that are, well, in a line, hence the name linear equations. And we can just draw that line through them. So a graph is just a way to speed up it's a way to represent plotting infinitely many points. Like if we tested every single number for x and found out what the y came out to, then that's some point on this graph. So just think of this line as a bunch of little dots, one after another. Okay, so now say we want to do that kind of more quickly. Like we can plug in points all the time and then draw a line, that's fine. But what if we just want to look at the equation and get a general idea of what's going on? Well, we can look at the m and the b terms. So for the m term, that's called the slope. And the b term, that's called the y-intercept. So in this case, 3 is the slope and 1 is the y-intercept. And so let's talk about why that is. So first of all, 1 is the y-intercept. Well, the y-intercept is just wherever the graph hits the y-axis. Here it's at 1, and you get that number by plugging in 0 for x, because that's what the y-axis is. The y-axis is the line x equals 0. So when you plug in 0 for x, then you get 1 now. Here, there's the y-intercept at 1. Yeah, in general, when you plug in 0 for x, that's just going to be m times 0 plus b. Well, the times 0 is going to make this part go away, and then you're just going to have the b left. So yeah, it makes sense that b should be the y-intercept. And then m is the slope. Well, the slope is just the amount of rising you do for every step right. So if you go 1 over right, you go 3 up here. Likewise, if you start here and you go 1 over right, you go 3 up. So that tells us kind of how steep our line is. So let's make up another equation and see if we can plot that right off the bat. How about, why don't we do y equals 4x plus 2. Yeah, how about that? So we'll draw our axes, x and y. So first thing, what's the y-intercept? Well, we saw before that it was 1, which is b. So in this case, it's going to be 2, because 2 takes the spot of the b here. Whereas 1 did before, now it's 2. So we're going to go here. Let's say this is 2. It's the y-intercept. And then the slope is 4. So that means every time we go over 1, we're going to go up 4. So starting at 2, going up 4, we get to, say, 6. And yeah, once you have 2 lines, then you can, or once you have 2 points, then you can draw the line through the points. Just to convince you of that, if we went to -1, then if we plug in -1 here, we get -4 plus 2 is -2. So that'd be down around here. And yeah, that makes sense. You can also think we're stepping backwards 1, so we go down 4. So 2 minus 4 will go down to -2. Yeah, okay, that makes sense. So what else should we talk about? Oh, why don't we try some more weird equations? I'm going to get rid of these drawings here. Whoops. Alright, so why don't we take something like y equals, what about -2x plus 1? So here, as we've seen this before, the y-intercept is 1, because that's the constant term, that's at the end, that's the b. So we'll plot 1, but now the slope is -2. So that means, like, if the slope were +2, then for every time you go over, then you go up 2. So -2 just means we do kind of that opposite. We go down 2 instead of going up 2. So we go over 1 and go down 2. So we'll just say this is 1. And going down 2 from 1 originally, 1 take away 2, you get down to -1. So our line looks like this. So let's just draw some lines with a bunch of different slopes. So we'll do another graph. We'll just say, we'll just make it go through the origin of a y-intercept of 0. So the line y equals x, that's like what, y equals 1x plus 0. So the slope, you'll start at 0, and then for every time you go over 1, you just go up 1. So that kind of line looks like this. Y equals -x plus 0, or just y equals -x. Well, that's like -1x. So we do a really similar thing, but we're going down 1 instead of up 1 when we go over. So now our line looks like that. I'm going to darken in these axes a little bit, just so you don't confuse them with the lines. How about y equals 9,999x plus 0. That's a huge number. So when we go over 1, then we're going to go up 9,999. Let's just say it's like way up here. And then make that line. So that becomes a lot steeper. As you increase the slope, the line gets steeper. It's like you're climbing up a hill. Like it's harder to climb. That's like the elevation of the hill. yeah, so this hill, well, I guess it's like a mountain, has an elevation of 9,990 feet. And then likewise, if we do y equals negative 9,999 x plus 0, then, well, now the hill is actually a valley, and it has a depth of 9,999 feet. So now when we go over 1 unit this way, going down to negative 9,999. And we draw that. So yeah, that's how you graph equations. Yep, that's all.